For the four-way test of the things we think, say, or do. First,
it is the truth.
Second,
it is very important.
Third,
we will well friendship.
Fourth,
we will make sure ourselves.
Thank you. Please be seated. Rotarian song. May we have PPF to lead us to sing the Rotarian song.
Hello.
R-O-T-A-R-Y, that spells Rotary. R-O-T-A-R-Y is North and sea. From north to south, from east to west, he profits most who serve the best. R-O-T-A-R-Y, that spells Rotary.
Thank you.
Thank you, PPF. Introduction of a visiting Rotarian and honorable guest. May we have Irene.
Hello everyone. Today is my honor, first time to introduce our guest. Today we have the handsome speaker, Bart Lissen from Holland. And then Cornell's friend, Wen Chen. And Yvonne. Okay, this is our guest today. Thank you. The big hand for me.
Okay, present time. Present.
All right. Well, thank you for P.P. Simon to take my seat last week, and thank you P.P. Euro for a great speech last week. And to report to everyone that we're gonna have our 32nd Charter anniversary on January 24th, Sunday night. So please welcome to join us and register as soon as possible you can. Next one. And the dress code is recommended like have a rock and roll style. Maybe just have one great leather coat, that would be wonderful. And in case that you cannot find a proper one, if you want to have a formal suit or a formal dress, that will be also okay. So just for fun. Okay, we have some good picture here that you can take as your reference. Yes, right. All right, so we commented to arrive around 5:20 that night, and we're going to sit in our guests in 5:50, and we hope to start the program with dinner at 6. And all the registration fees like this, a member and +1, so free. Any guest that you invited to welcome, but per person the registration fee would be 1,000. That's okay, and this week our badminton team is still going, and we have a wonderful time. Thank you all. All right, that's my part. Thank you.
Thank you, President. Secretary time, we are going to have a STAR meeting in January 21st. May we have PP Juice to share some information for us?
Okay, thank you. As I was appointed to be the STAR meeting chairperson, so we'll have our first STAR meeting on January 24th. Actually, that day is our meeting day, but because we're going to have charter ceremony, so most of you don't need to come. However, we got a new member. Brand new, Irene, and also we have 3 veterans. We have Min, Vito team. They are less than 2 years in Dato membership, so they also need to attend. I also invite President Asen and secretary team. Actually, he is also a new member, and also as our boss. Simon, he is the chairperson of the membership, and also our president-elect, Jimmy. So they will be my, assistant teacher to exchange some new information. So we'll see you, not most of you, I mean, these people, on 21st. Thank you.
Thank you, James. Okay, the January board meeting will hold on next week, January 14th. So all the board members, please reserve your time to attend. Okay, we are going to our main program. May we have Cornell to give us the speaker introduction.
Thank you. You really try to help us to get enough time for our speaker to give today's speech is really, really valuable for everybody. It's a great honor that we can have this opportunity to invite Bart here to share his experience and his knowledge on the wind energy. Bart has been living in Taiwan for 20 years. But I don't know how well his Chinese is. Supposed to say pretty good. I think it's good to know that he actually is the managing director for Enercom company. And he is in charge of the installation and the maintenance of wind turbines. So you know how important he plays the role in the company. And his company actually is the 5th largest company in manufacturing wind turbines. It's hard words in the world. And right now, there are about 230 wind turbines installed by his company in Taiwan, which occupy 70% of the market in Taiwan in this field. And in the meantime, Bart is also the executive director of European Commerce Chamber, 欧侨商会会长哈。I know that all of you have been listening to lots of speech given by scholars or scientists or even politicians. So I think today it's good that we have someone who can share his knowledge, the hands-on experience with us, and perhaps you know some difficulties he encountered in his field at work. So let's invite, welcome Bart over to share.
Thank you, Mihua. I feel a lot of pressure now. I do need to have a minute to set up my laptop because I've prepared some pictures to make it more entertaining.
So actually, we got thanks for the Mr. Bart. You know, we have never had that accessories or decoration like this windmill. It's pretty, must be not easy to do that windmill model here.
Okay, I think I'm good to go now. So, yeah, thank you for inviting me. It's really an honor and a pleasure to be here. I like to talk about my work, so stop me if the time is up. Because that's probably the one problem that I have. So let me first tell you what I will explain to you today. So I've split it in 3 parts. The thing that you need to know first, I'll tell a little bit about myself and also a little bit about the background of this industry. I will explain you the technology. That's super easy, so that will only take a minute or so. I will explain you the strengths of wind energy, what the benefits are of this technology. And in number 4, the winds of change, I will explain you briefly what is happening in Taiwan right now, because I think you may see something in the news. I'll try to tell you a little bit more of what's going on. So what you need to know first. Maybe what you need to know first is that I'm from the Netherlands, and the Netherlands had a lot of windmills. Historically, I think we're quite famous for that. And what you may not know is that actually the Netherlands had 14,000 windmills at somewhere in the 1800s. So there were a lot of them. There are not so many anymore. We only have a couple of hundred left. So I was born in the Netherlands. I studied in the Netherlands. I studied electrical engineering. And during the study, I did a side, how do you call it, a subject on environment and sustainability. And in this course, this graph was shown, and maybe some of you know this, maybe you don't, but I cannot stop myself from explaining this graph because I think it's so essential in, first of all, why I'm doing this job, and why I think this kind of technology is so important and we should really look into to doing something. So what this graph shows is there's a timeline here, so from now until 400,000 years ago, and you may know or you may not know that scientists were able to determine the CO2 levels over those 400,000 years. So how did they do that? Basically they drilled into the ice, maybe in glaciers or in the North or South Pole, and they looked at the little air bubbles in the ice, and they were able to determine how much CO2 there was at that time. And what you can see is that level of CO2 goes up and down. So over 400,000 years, this is roughly the fluctuation, and you can also, they were also able to determine that when CO2 is less, the temperature is colder, so you would have an ice age, there's more ice on the world, and when the CO2 levels were higher, the temperature was warmer, more comfortable. So actually right now, we are at a moment in time where this was going up. So we just came out of the ice age and the world is warming up. What then was also very important to know or to notice is that CO2 level was never under 180 parts per million and never over 300. So over 400,000 years, yes, it got colder, it got warmer, but it was never, the CO2 levels were never under 180 and never over 300. And that was, in fact, until, so again, like I said, the last ice age was around here, 20,000 years ago. And in the 1800s, we were somewhere at that point. And the thing that at that time really shocked me, and I hope it also shocks you if you don't know it yet, is that CO2 level is increasing a lot and incredibly fast. So from 1800 until now, we have increased this level significantly. Does anybody know the current parts per million level of CO2? Anyone try to guess? So we're right now there.
Good.
And it's at 400. 412. And you can also see there's websites that you can go on. This increase, this going up of the CO2 level is it's year by year higher. So it doesn't go up and down, it just increases year after year. There's a fluctuation over the year, but if you compare May this year with May last year, you will always see an increase consistently. It never stops. And that, at that time, really worried me, and that's now 30 years ago or so. And what now really worries me is that nothing really changed. So I'm really concerned right now. And so that's why I want to start with this, because this is also the whole reason why I decided to do this job. I think this is part or one of the solutions to this, and also the reason why I like to do these talks, because I hope that more people are aware of this. And so that CO2 level goes up, it's 400, and you can also see that if you look at the average temperature. So what you see here is the global average temperature, and here is the counter of the year. So it runs from 1900, and you can see that, yes, it gets warmer, it gets colder, we have a few years of cold and a few years of hot, and that's all very normal. But you also see very clearly that 1990, we're now 2000, that it's really getting a lot warmer than it was 100 years ago. So it's getting very, very significant, this increase. And also keep in mind that, and I forgot that in the last graph, that we had that difference between 300 and 180. 180 is, if you were living in New York, it would mean 2 kilometers of ice above your head, and 300 would mean comfortable climate. So what does it mean if we go from 300 to 400 or even higher? That difference could be huge. And I think it's our responsibility to make sure that the generation after us still has an enjoyable environment to live in, and that's where I think we have to do something. Okay, so 180, 300. There are people that will say, well, but, yeah, and it's 400 now. There are people that will tell you, yeah, it was 400 before. It's not unusual for the Earth to have 400 parts per million of CO2. And these people are right. However, it was 400 parts per million 3 million years ago. And at that time, the world was completely different. And we had a camel-like species living on the North Pole. But it was a completely different environment. And we are heading on that. And on top of that, we are heading to that in record speed. Because I can prove that, but the speed in which we are increasing the CO2 in the air is also unprecedented. We never do this before. Yeah, so it's really an experiment that I think we don't really want to do. And we can solve this problem just by ignoring it, which is basically, from my view, what we've done for 30 years, until finally our ass will be on fire. So, yeah, so nothing much has happened, but I do want to close this chapter with something positive, because actually in the last 5 years, I do see some movement. So I do see that people are getting aware that this is really a problem. And what encouraged me the most is that you see that especially in business. And why does that encourage me? Because they are actually the ones that can really move it forward. If there's money involved, a lot of things are possible. So these companies that you have here, and you can see there are some big names here like Lego and Apple, and Google is somewhere, Nike, all these big names, they have already committed that they will be 100% renewable. That's why they are a member of this organization, RE100. They have different timelines, but they've all committed to become 100% renewable. And if these companies have that objective, and again, there's money involved, I think that will be a good step towards really realizing that. Okay. That was just basic, and maybe to explain what motivates me and yeah, what keeps me going every day. Technology, like I said, that's really simple. I brought one for you. In reality, they're a little bit bigger. So this, we are at 1 meter and 70 centimeter. A real one that we've installed in Taiwan would be 64 meters high. And I will tell you now how it works. And so for that purpose, I need to remove one blade, so that is always a bit tricky. Managed to do it. So, what people don't know and what you need to know first, and which will hopefully explain almost everything, is that this part of this wind turbine, it can turn. Its angle can turn. Okay? That's the first thing. And the second thing is that this part, we call this the nacelle, it can turn as well. Yeah, so this whole, not the whole thing, but the top part turns, yes, and this turns. So why does the top part turn? Very simple, the wind doesn't always come from the same direction. So it has to look for the wind. So what the turbine does, what this wind turbine does, is it looks for the wind. It has a sensor for that, it knows where the wind direction is, and then the whole thing entirely will move in that direction where the wind is coming from. Now, after it has done that, and it is in the right position, it will turn its blades. Because if the blades are in this position, 90 degrees towards the wind, they will not move. It will just stand there. It's a bit like the airplane wing and what makes an airplane go up. And so this will turn, this angle will turn in the direction of the wind, and then slowly the whole thing will start to turn. And that's all there is. That's very easy, because that will then also explain, for example, I get that question often, what happens during a storm? I think you know the answer already. So during a storm, very simple, or during a typhoon, it just turns back and the whole thing stops. Or just idles slowly. Yeah. So start, stop. Yeah? Okay. Any questions?
So when the typhoon came, the windmill will still operating, or you would like to stop it?
It will stop automatically if the wind speed is too high for it. Yeah. So it will basically, what it does is it will determine the wind speed, and then because the control, yeah, now it gets maybe difficult, but the control system will try to keep this rotation speed constant. So if the rotation speed, as soon as it gets too high, it will pitch, we call this pitching, it will change the angle further and further until finally it's completely out of the direction of the wind. And if the wind speed then still gets higher, like typhoon wind speeds, it will completely stop and just, it will turn a little bit, but not much. And in that way, it's perfectly safe. We've never had any damages from typhoons. So you can work with that.
Why all the wind, this equipment only 3
blades?
Yeah.
Yeah, that's a good question. Actually, yeah, that's a perfect question, and there's no good answer, because you can make wind turbines with 1 blade. You can make wind turbines with 2 blades, with 3, 4, 5, 6. It's all possible, but 3 blades is kind of an economic optimum, because if you make 1 blade, it's both an economic and technical optimum. If you make 1 blade, it's harder to keep the towers the balance. With 3 blades, it's easier. Also, the amount of material that you need to keep the blades strong and withstanding the wind. So there's an optimum there, and that's why people, generally 3 is the optimum. But anything is possible. 3, 4, 5, 6. You can do all of that. It's not necessarily have to be 3 blades.
Like in your country, Netherlands, the
4.
wind, yes, they have 4.
Yeah, that's right.
Interesting.
It's possible, yeah. It's all possible. Okay, so now you know how this turns. So now let's have a look quick what is inside. I have a picture of that. Let's see if I can make it work. So that's that egg shape that you see on the top, and then you are looking what is inside. So here is the blades, they are connected, it's turning. These blades are connected to this machine, this is a generator. And all that a generator does is transfer movement or rotation into electricity. And that's it. Because then the electricity goes, some funny equipment here, but that's not really relevant. It goes down, it goes to the bottom. It's transformed, it's changed into electricity that the grid, that TPC can accept, and it's connected to that. So basically you just need to take a cable and you plug it in and you're done. It's the same as that when you plug in your computer, electricity comes out. In the same way, you can plug this in and electricity goes in. And it's shared with everyone. So what this turbine generates, or that turbine, as soon as it's plugged in, it goes to everyone. So this light that we have here on, some percent of that is produced by our wind turbines right now. Yeah, but because everything goes together, you don't know which comes from where. And that's it.
Yes.
So there are two types. One is on the ocean, one is on the land.
I come to that. Very fast very fast audience today. Because actually that's my next point. Onshore and offshore.
Offshore. Okay.
And I have to also explain that because my company and me, we only do onshore. Yeah, that's a choice by our management, and there's some reasons for that, but that's all we do. So what's the difference? Not that much. In onshore you use a car, and offshore you use a boat, and onshore will cost something, and offshore will cost you double something. So it's a lot more expensive. Does that answer your question? Or is that not detailed enough?
On both types, they need a welding.
There's all welding, yeah.
Okay.
Yeah.
So I was told that the what you call the underwater welding is more difficult than the offshore type.
That's one of the reasons why this is. So everything about offshore is a little bit more difficult. And so technically it's more challenging. So why do people do that? I think there are two reasons. One is if you just put it in the sea, nobody will complain. Because it's way, that's one reason, number one. The other reason is more technical, because it's flat. Yeah, so the sea is quite flat, and that increases the production of the turbine. So you can have a higher production, a higher energy generation than you would have on land. But at the same time, you have to invest more money to create that. So it's a bit of a balance there. Okay? Okay, then chapter 3. Are we still?
One question.
Yeah, sure.
When you say offshore, the definition is how far from the land?
Oh, that's a really good question, because actually I had discussion with our. Now I have to tell you something. So I told you we only do this, right?
Yeah.
And we will also explain later that in Taiwan there's a lot of this.
Yes.
So actually my sales person was asking me the same question, because you can do onshore by just making a little bridge into the water. So his idea was, why don't we build a bridge from the beach and then put all the turbines on there? Then you have offshore, and it's with an onshore turbine. So I don't think there is really a very clear definition. But for me, I would say it's really offshore if you have to go there with a boat, and where it's a lot more complicated to install these things. So onshore you install with a standard crane, you have standard equipment that you use for that, the offshore is really very specialist. But where the limit is, I cannot answer that. So the power of wind. So I'm gonna, so this part of the presentation is a bit silly. I will warn you that now, because I try to use a more entertaining way to explain you some of the benefits of wind power. And basically the idea is that I'm going to sell you a wind turbine. So we'll do a little sales talk, but it will look really, what's the English word? Corny or silly. So, so there we go. So your lungs are dirty. You want clean lungs. You need lung cleaner 2.0. Let's have a look. Lung cleaner 2.0 is clean. No PM 2.5, PM 0.0. Lung cleaner 2.0 is small. One lung cleaner is equal to 20,000 solar panels. So let's say you have a rice field somewhere in Taiwan and you want to do renewable energy, you have a choice. You can put solar panels, or you can put lung cleaner 2.0 and still grow rice. It's quiet.
Really?
Really?
Really? At a distance of 100 meters, it's 50 dB. So what is 50 dB, anyone? What's the sound level of 50 dB?
Like bicycle riding?
Yeah, could be, yeah. So that's like your window air conditioner. If you go a little bit further, 400 meters, it's 40 dB. Doesn't sound like much, but it's a lot more quiet. But I want to point out something here first. This is a picture taken in the Netherlands, and the farmer lives here. There are two interesting things about this picture. First of all, this is the farmer's old turbine from 30 years ago. So please compare the size. And also please note that he put his turbine right behind his house, so he can hear if it's working or not. This farmer, or these farmers, they are participating in this project. So they are the ones that are actually, that were building this project. But back to the original question, 40 dB. 40 dB, that would be the sound level of your refrigerator. I had a little video in which you could hear the sound level, but I didn't prepare it today because I was worried that we're running out of time. What I suggest instead is that go and listen for yourself. The only way to really appreciate and understand the sound level of a wind turbine is to go to the sea and listen to what the noise actually is. And yes, you can hear it, but no, it's really not that loud. Usually the sound of the sea and the wind is what you hear and not the turbines. It's safe. Maybe that's might be another surprise. So we have typhoons in Taiwan, we've had Haitang, we had Morakot, we had Sudalar. We have 18 years of lung cleaner 2.0 in Taiwan, 18. We have 233 lung cleaner 2.0 installed, and we never in those years had any damage from typhoons or earthquakes. It's cheap. It's actually very cheap. It's not 6 NT like offshore would probably cost you. It's not 5 NT like PV, the cost of photovoltaic. It's not 4 like when you burn gas to produce electricity. It's 2. And 2 is a conservative number. On top of that, it's going down every year. So every year, the cost of wind turbines, the cost of the electricity that wind turbines produce is less. And actually, our company is currently developing a new series of turbines, and the target by management for these turbines, the target cost, is 0.5 NT dollar per kilowatt hour. And I don't know if you ever check your electricity bill, but Thai Power sells you the electricity for 3 or 2.7 or something like that. So it's a good deal. It's also local. We do all the service maintenance installation with local staff. So we actually have a training center for the region. So our company services the other countries in the region. We also send our technicians to Japan, Vietnam, Korea. So it's a good opportunity for young technicians. So I do believe we help to make Taiwan great again. So your lungs are dirty, you want clean lungs. Lung cleaner 2.0. Any questions? Yeah, okay.
If according to your calculation, it's about 220 to produce, how come our government is encouraging you to build offshore turbine? They say that Taiwan Strait is the best wind field in the world. That's why we need the offshore.
So it's true. Taiwan has some of the best wind conditions. I think, so my understanding is that the government is promoting offshore because it's hard to do onshore. And maybe we can have some Q&A later about that. It's not easy for us to get the permission to install an onshore wind turbine because of the same reason that all of you already know. Most people will think they are noisy, most people will think they are expensive, and that they are not safe. That blades will be blown off by typhoons, and we can talk about that. But I actually hope that by showing that that's not the case, that you can build them safely, that the noise level, that it is there, but it's manageable, and that the cost is very cheap, that there's still some opportunity. And I have some suggestions for that. But you are right, the Taiwan government is focused on offshore, and I believe to avoid any, as much as possible, arguments. Or maybe now the fishermen are protesting, but for most of us it doesn't affect us.
May we pay a call to you someday?
You may always call
and
me.
have a look.
Yeah. Welcome. I actually said that before. Welcome to visit our office. We have a training center.
And have a look of the rear.
You can have. We can take you there. I cannot take you up, but I can have you. I can have you.
At least the field.
You can go and look and listen, and we will introduce. Please welcome. I invite you now as well.
Really?
Sorry, no, sure.
You mentioned it's cheap and
Yes.
also it's clean.
Yeah.
I'm curious because in Taiwan we have over 23 million population with lots of industry.
Yeah.
So how's the total electricity needed, and how much the percentage possibly provided by wind?
Yeah, I think that the answer depends on how ambitious we are. I think the total. So first of all, wind energy is not the answer for all your electricity needs. That's impossible. We cannot. I think Taiwan needs 60 gigawatts or something like that. We can never do that. But you would need to look for a combination of renewable energies. You can look for PV, you can look for offshore wind, you can look for onshore wind, and you could look for any other technology that becomes available. And that package should be possible to produce most of the electricity, or maybe even all of the electricity by renewables. I'm convinced of that. Yeah. But right now it's not so much. It's 1 to 3%, depending on what you include. Yeah. So let me.
Two questions. One is, what is the major factor contributing to reduce the carbon
Okay.
The second question is, from your experience or your knowledge, I mean, is it feasible that to develop a smaller system which can be used in household even, or at least for the community?
Yeah. So. I think the answer to the first question will answer your second one. The reason that you can go cheaper is that you go bigger. So you will have turbines with bigger blades and bigger capacity and a simpler system, and that will reduce your cost. And also you can mass produce them. So that will reduce your cost. If you're going for smaller, those costs will increase because you need to maintain all the little turbines. So I'm not, the cost of these small turbines that you put on the rooftop, they are quite significantly higher than this one. And this is also where some of the misunderstanding comes from. In Taiwan you have a feed-in tariff for wind energy. And there's two different levels. One is for 5 kilowatt and below, so that's your small turbine this size. And the other one is for the big turbines. The small turbines, they get a feed-in tariff of $6 NT per kilowatt hour. Until now, 6 or more. The big ones, this one, the one that we manufacture, gets only 2 to 2.6, depending on which year it was built. So this also shows that the cost is lower than 2, because even with 2 NT in income, our customers are able to survive. Not yet satisfied.
I think one of the major obstacle actually is not only by government but also by the tide power, because there are also so-called the tide power is also one of the concern part, how we call it, the interest.
Yeah, but they have completely changed.
Yeah, so actually if you have the really lower cost, there should be some opportunity that to sell directly the facility to people who has a bigger land, which because they can get some saving from the electricity, right? So they get like TSMC, and they probably can have their own wind power system. How do you see this? I mean, is that feasible or not?
That's possible now. Let me do it like this. I'll finish this, because actually my last part connects to your question. I'll finish the last part, and I will explain the developments in Taiwan right now, because what you are saying just now, that you can produce your own electricity, that's possible now. And that's a very important reason why I believe that things will change in the coming 2-3 years a lot. So, but let me finish this then. So a bit about Taiwan. I will do offshore very quickly, because first of all, I don't understand it. But I think to be the story complete, I will let you know. And also because it's right now the biggest focus for everyone to look on. So these are the current plans. Hopefully this is correct, because they keep changing the numbers. But the target for the number of turbines and the number of capacity that is going to be installed offshore is gigantic. It will be 15 gigawatts, so then we are talking already 20% or so of Taiwan's power needs. There will be 1,500 turbines, and you probably need 20,000 people to install and maintain them. So this is a huge industry that is currently developing. Okay, yeah, so I just mentioned that, so that would produce already enough for 21 million households. So where is this happening? I think that's something that probably everybody already knows. So there's a lot of development in Zhanghua here, and we have some wind farms up north. And a lot of the developers are from Europe. You have this Danish company, Ørsted, you have CIP, there is a German company, WPD, and Taipower is also having a few projects. So these developments are absolutely huge. Regarding onshore, there's not so much going on. So it has been very quiet, but I will show you what we have right now. So these are the wind turbines that we have installed right now. You can see they run roughly from just north of Taoyuan wind farm up until just south of Zhanghua. And there are 233 turbines there. 233. So I think there's still potential in Taiwan to have more, but we will have to solve the problem of the opposition of the residents. And one of the ways that I see as a way to move forward is what they call community wind. This is very popular in Europe, and with community wind you invite residents to participate, to take shares in the company that owns the wind farm. And what we have seen in Europe is that if you do one demonstration project, basically all the villages around it will like it too, because there is 6-7% interest on the investment, which is not a bad deal, and it's a very stable income for 20 years for them. So this is one way that we could go. The other way that I'm promoting that I think we should make it, we talked about noise. Well, if you put the turbines next to a highway, which is also safe, then you don't really have, you cannot really argue the point of noise. Harbors is something that is not considered yet in Taiwan. I know that there are people looking into that. Harbors are an excellent location, there's good wind, it's next to the sea, and there is the space. So this is something, this is a project in the Netherlands that we did, and that could be done in Taiwan as well. And the final one is a combination with industry. So if you have a factory and you just need a little space around your industrial park or next to your industrial park, and you can install your wind turbine. And so I will close today with a little video of Heineken, because they actually, in the Netherlands, they installed 4 turbines for their brewery. So let's have a look at that, how they did that. They are Cheers. So why is this important? And then that will answer your question. I think that something has changed in Taiwan in 2017, I believe, with the passing of the Electricity Act. Not sure if you're familiar. The Electricity Act purpose is basically to, in the end, it's to cut up Thai power and privatize the electricity market. And they're doing this in steps, with the first step for renewable energy. And the practical implementation, that has taken some time, but from this year, there is a practical implementation for renewable energy. So you can sell your electricity that you generate with your solar panel or your wind turbine directly to a consumer. And you've probably all read the news of TSMC buying the electricity from Ørsted. That is one of the first examples from that. And our own customers, so the owners of our turbines, they are doing exactly the same. Why is that important for onshore? Because it's so cheap, and because it wasn't really supported by the government feed-in tariff before. So our customers from Thai Power, they only got 2 to 2.5, 2.6 NT dollar per kilowatt hour, and that was it. I'm sure that if our wind farm owners go on the market and look for customers directly, that they can get a higher tariff. You saw the RE100 customers, the RE100, the Renewable 100 members. They have a target for 100% renewable energy. They need to buy their renewable energy somewhere. At this moment, renewable energy in Taiwan is not enough. So there's going to be a struggle for renewable energy. And TSMC is very fast. And I already heard that some of the other semiconductor companies are now complaining because there's nothing they can get. And they cannot buy this renewable energy. So that's one thing. On top of that, the Taiwan government has implemented this requirement to have 10% renewable energy for your own facility too. So, and that, in my opinion, will really change things in the coming years. And people really start to think about how they will achieve this renewable energy goal and start looking for cheaper solutions. I think that will be a new push also to do something onshore. Okay, thank you.
And shall we take a picture together? And there is a little souvenir. Yeah, maybe around the winter. Cornell, please.
Thanks.
One more.
All right, thank you.
Thank you.